Welcome back to the deep dive. Today, we are focusing on something that, well, it sits in almost every kitchen cabinet in the world, usually in a cardboard cylinder, completely ignored. We're talking about iodine. But before you think this is just a PSA about table salt, looking at the research we've pulled, this is actually a story about the architecture of the human brain.
It really is. It's so deceptive because iodine, it feels so mundane. But when you dig into the biochemistry, it's arguably the Goldilocks mineral of our biology.
That's the phrase that stuck with me, the Goldilocks mineral, this idea that we're all walking this tightrope. On one side, you have deficiency, which literally breaks the machinery of life. On the other, toxicity, which can shut your organs down. And that window between just right and disaster is it's terrifyingly narrow.
It is a razor-thin margin. And what makes this deep dive so relevant right now is that for decades, we thought we had this solved. Universal salt iodization USI that was supposed to be the silver bullet. But the data suggests the safety net is full of holes.
The silent slide, that's what the reports are calling it. We are seeing a regression. The World Health Organization estimates that nearly 2 billion people globally have an insufficient iodine intake.
2 billion. It's a staggering number.
And the paradox here, and this is what we really need to unpack, is that the people most at risk today, they aren't necessarily in developing nations.
No, not at all. It's the health-conscious populations in wealthy countries.
Yeah.
Exactly.
Yeah.
It's the people avoiding processed foods, the people switching to plant-based diets.
Hmm.
We are, well, accidentally engineering iodine out of our lives in the pursuit of clean eating.
So let's establish the stakes here. Before we get into that dietary minefield, why does biology care so much about this one element? I was looking at the soil distribution maps, and they're chaotic. Iodine is everywhere near the ocean, but you go inland, the Alps, the Himalayas, even the central US, and it's just not there. Why build a whole biology dependent on something so unreliable?
That is the great evolutionary gamble. Biology cannot synthesize iodine. It's an element, right? Atomic number 53. You have to eat it. But once it's in the system, it becomes the absolute raw material for the thyroid gland. And the thyroid, well, that's the engine room.
Right, the furnace of our metabolism.
And think of it that way. The thyroid produces two main hormones, T4 and T3. Now, the T in those names literally stands for the number of iodine atoms attached to the molecule.
So T4 is thyroxine, 4 iodine atoms.
Right, and it is 65% iodine by weight. T3 holds 3.
So iodine isn't just a helper or a catalyst that speeds things up. It is the actual structure. It's the brick and mortar of the hormone.
Precisely. Without iodine, you physically cannot build the molecule. It's like trying to frame a house with no wood. And these hormones, they don't just regulate how fast you burn calories. They control protein synthesis, enzyme activity, body temperature, physical growth. If the supply of iodine stops, the machinery of life just grinds to a halt.
Okay, so we consume the iodine, it gets into the bloodstream, but the concentration of iodine in the blood is, it's pretty low compared to what the thyroid needs, right? So how does the gland actually grab it? The sources describe something called the NIS, which sounded like a piece of industrial equipment.
It acts like one. NIS stands for sodium-iodide symporter. So imagine a high-powered vacuum cleaner, or maybe a pump, sitting on the membrane of the thyroid cell. The concentration of iodine inside the thyroid is 20 to 50 times higher than in the blood. So naturally, by the laws of physics, iodine wants to flow out, not in.
It's fighting the gradient.
Right, it's swimming upstream. So this NIS pump, it uses the electrical energy of sodium, which wants to rush into the cell to drag the iodine in against the current. It's incredibly efficient. But here's the detail that usually gets glossed over, and it's crucial for where we're going later. The NIS pump isn't only found in the thyroid.
I saw that list in the papers. Salivary glands, the stomach lining, and lactating breast tissue.
Which forces us to ask, why? If the NIS is just for making thyroid hormone, why is the stomach hoarding iodine? Why is the breast pumping it? We will circle back to that, but keep it in mind. The body is prioritizing iodine delivery to these specific organs for a very distinct reason.
So what happens when that pump runs dry? If I switch to sea salt and stop eating dairy and my intake drops below that, 50 micrograms a day, what's the physiological sequence?
The system panics.
Yeah.
The brain specifically, the pituitary gland senses that T4 levels are dropping, so it screams at the thyroid to work harder. It releases TSH, or thyroid-stimulating hormone.
Work harder, build more.
Exactly. TSH tells the thyroid to multiply its cells and ramp up the NIS pumps to catch every single stray atom of iodine flowing by. Physically, the gland gets bigger. That's the goiter. It's not a disease in itself at first. It's a desperate adaptation. The thyroid is increasing its surface area to try and catch rain in a drought.
But a goiter is visible. You can see the lump in the neck. What really freaked me out in the research were the invisible consequences, specifically for the brain, for intelligence.
The neurological impact is the real tragedy of deficiency. We are not just talking about being a little tired or sluggish. We are talking about the structural wiring of the brain.
There was a specific stat about IQ points that I had to reread.
Yes, meta-analyses show that chronic iodine deficiency in childhood can knock about 13.5 points off a person's expected IQ.
13.5 points. That is a massive shift. That's the difference between average intelligence and being gifted or struggling in school versus succeeding. It changes the entire trajectory of a life.
And it shifts the economic trajectory of entire nations. If a significant portion of your population is operating at a cognitive deficit because of their diet, your workforce productivity just plummets. But the most critical window isn't even childhood, it's the very beginning.
Pregnancy.
Specifically, the first 10 to 12 weeks of gestation. At that stage, the fetus does not have a thyroid, hasn't grown one yet. It is 100% parasitic on the mother for thyroid hormones. The mother's T4 has to cross the placenta to tell the fetal brain how to organize its neurons.
The term used was neuronal migration.
Correct. The neurons have to move to the specific right places to form the cortex. If the mother is deficient, those neurons, they don't migrate correctly. The architecture of the brain is flawed from the foundation up. This isn't something you can fix with tutoring later on.
And that leads to cretinism.
In the most severe cases, yes. Neurologic cretinism involves severe intellectual disability, deaf mutism, motor spasticity. It's irreversible. And because the fetus is pulling so hard on the mother supply and her kidneys are clearing iodine faster due to pregnancy, her own requirement just skyrockets.
The numbers in the report showed a 50% increase.
At least. The standard recommended dietary allowance, the RDA, is 150 micrograms. A pregnant woman needs 220 to 250.
Okay, so here is the frustration point for me. You would assume logically that every prenatal vitamin on the market would account for this. If it's the single most preventable cause of brain damage, surely it's in the pill.
You would think so. But a study analyzing the U.S. market found that about 40% of prescription prenatal vitamins contain zero iodine.
Zero. That seems almost negligent.
It's a massive gap. And looking at over-the-counter brands, it's also spotty. The data shows that only about 18% of pregnant women are actually getting adequate iodine from their supplements. It's a massive blind spot in prenatal care. Doctors often assume the diet covers it or that the vitamin covers it, and, well, frequently neither is true.
Which brings us right to the modern diet paradox. We touched on this, but let's break down the mechanics. Why is a healthy diet in the 21st century potentially an iodine-deficient diet?
It's the law of unintended consequences. Let's look at the two main sources of iodine in the Western diet, salt and milk.
But not just any salt.
Right. Iodized salt is a processed product.
Right.
It was a very intentional public health intervention started back in the 1920s to stop goiters. But today, the trend is toward natural salts.
Sea salt, kosher salt, Himalayan pink salt.
Right.
They taste better, they have better texture. I have 3 different kinds of sea salt in my kitchen right now.
And most chefs do. But biologically, they are useless for iodine. Sea salt, despite coming from the ocean, loses its iodine during the evaporation process. And Himalayan salt is mined from ancient deposits that never had much to begin with. So if you swap your generic table salt for, say, molten sea salt, you just zeroed out that source.
And then there's the milk. This one really surprised me. The iodine in cow's milk isn't natural.
Not really, no. It's
Yeah.
largely accidental. Dairy cows need their udders cleaned to prevent infection, and the industry uses iodine-based sanitizers. Some of that iodine leaches into the milk. Plus, the cattle feed is often fortified. So a cup of cow's milk might give you 50 to 100 micrograms, which is huge.
But if I'm drinking almond milk or oat milk?
No udders to clean, no fortified feed.
Well,
Unless the manufacturer explicitly adds potassium iodide, which is rare. Plant-based milks have maybe 3 micrograms per cup.
so the modern health-conscious shopper who avoids processed table salt and has swapped dairy for oat milk is effectively walking right into a nutritional trap.
That is the profile of the new deficient. It's not about poverty anymore. It's about food choices.
Now, I have to ask about goitrogens. The articles mention broccoli, kale, soy, cassava. I feel like every time we talk nutrition, someone tries to take away my vegetables. Do I need to stop eating salad to protect my thyroid?
Okay, let's dial back the alarmism on that one. Goitrogens are compounds that can interfere with the uptake of iodine. They compete for that NIS pump we talked about. However, the literature is very clear. For a person with sufficient iodine intake, eating broccoli or tofu is completely fine.
So the kale isn't the villain.
No, the villain is the combination. If you are already deficient because of the salt and milk issues, and you consume massive amounts of raw goitrogens, then you have a problem. It tips the scale. But if your iodine levels are solid, your thyroid can handle the broccoli just fine.
Okay, that's a relief. So the fix seems simple, supplements. But the deep dive materials had a warning about the gold standard versus the wild card.
Right. The gold standard is potassium iodide. Ki, that's what's in the high-quality prenatals. It has 96% bioavailability. You take it, your body absorbs it, it's predictable.
And the wild card is kelp?
Seaweed, kelp, kombu. A lot of people think, I want a natural source, so I'll take a kelp pill. The problem is the variability. One pill might have 100 micrograms, the next could have 2,000. It depends on the water temperature, the season, the species of kelp. It's unregulated nature.
And we also saw that preparation matters a lot if I make a soup with kombu.
If you boil kelp for 15 minutes, you strip out about 99% of the iodine into the water. If you eat the kelp but throw away the broth, you get nothing. If you drink the broth, you get a massive dose. It's just very hard to dose accurately with food sources.
And dosing accuracy matters because of the other side of the coin, the Goldilocks thing. What happens if we swing too far and get too much iodine?
You trigger the Wolff-Chaikoff effect.
Which sounds like a Cold War thriller.
It does, doesn't it? It's a biological emergency brake. If you suddenly flood the thyroid with a massive amount of iodine, the gland doesn't just make super amounts of hormone. That would be dangerous. It would cause a thyroid storm that could send your heart rate through the roof. Instead, the thyroid it shuts down.
It just stops working.
It completely halts hormone synthesis. It locks the doors. In a healthy person, this lasts about 48 hours. It's called the escape phenomenon. The thyroid downregulates the NIS pumps, takes the vacuum cleaners offline, so the iodine levels drop inside the cell, and then it restarts.
But not everyone restarts.
Exactly. If you have underlying autoimmune issues like Hashimoto's thyroiditis, your thyroid might fail to escape. The shutdown becomes permanent. You essentially give yourself hypothyroidism by trying to prevent it.
Is this common from diet? Can I get Wolff-Chaikoff from eating too much sushi?
It's very hard to do with food, unless you're eating seaweed salad 3 times a day, every single day. We mostly see this in medical settings. The classic example is the drug amiodarone.
The heart medication.
Yes, for arrhythmia. Amiodarone is 37% iodine by weight. A single daily dose can be 35 to 140 times your daily iodine requirement.
Wow, so you are just hammering the thyroid with a sledgehammer every day.
And that can trigger type 1 thyrotoxicosis, which is making too much hormone, or type 2, which is actually destroying the gland cells. It just highlights how potent this element is. It's not just a nutrient. In high doses, it acts like a drug.
This brings us to the part of the research that I found the most surprising. We've talked about the thyroid, but you mentioned earlier that the NIS pump, that iodine vacuum, is also found in the breast and the stomach. Why?
This is really the frontier of iodine research. The prevailing theory is that iodine isn't just for hormones. It's an antioxidant and an antiproliferative.
Antiproliferative, meaning anti-cancer.
Potentially. We know that breast tissue concentrates iodine, specifically molecular iodine, I2. When iodine levels in breast tissue are high, it seems to stop cells from dividing uncontrollably. It creates an environment that's hostile to cancer.
Is there clinical evidence for this, or is it just theory?
There's strong observational data. Japan has one of the highest iodine intakes in the world because of seaweed, and historically they've had very low rates of breast cancer. When Japanese women move to the U.S. and adopt a Western diet, their breast cancer rates rise to match the local population.
Correlation isn't causation, though. There are a lot of factors in a diet change.
True, but we also see it in animal models. If you induce breast cancer in rats and then give them iodine combined with chemotherapy, specifically drugs like doxorubicin, the tumors shrink significantly more than with chemo alone. It suggests a synergistic effect.
And for non-cancerous issues, the notes mention fibrocystic breast disease.
That's actually where we have the best evidence. Women with painful, lumpy breast tissue fibrocystic changes often see significant pain reduction and regression of the fibrosis with molecular iodine supplementation. The iodine seems to reduce the inflammation and the scarring.
That is incredible. And the stomach. Why does the stomach need an iodine pump?
The stomach lining concentrates iodine to secrete it into the gastric juice. The hypothesis is that it acts as an endogenous antibiotic.
A built-in sanitizer.
Exactly. Think about povidone iodine, the orange stuff surgeons use. It kills everything. Bacteria, viruses, fungi. It works Because iodine is an oxidizer. It just rips electrons off the cell walls of bacteria. They can't develop resistance to it because it's a physical attack, not a chemical key that can be changed.
So by concentrating iodine in the stomach, the body might be keeping things like H. pylori in check.
That's the thinking. H. pylori is the bacteria that causes ulcers and is linked to gastric cancer. And populations with low iodine intake often have higher rates of stomach cancer. So the NIS pump in the stomach, it's not an accident. It's an immune defense system.
This changes the whole conversation. We define iodine sufficiency as not getting a goiter, but that definition completely ignores the breast and the stomach.
That is the crux of the argument. We have set the bar at survival. We prevent the gross physical deformity of the goiter. But are we getting enough to optimize our IQ? Are we getting enough to protect breast tissue from neoplasia? Are we getting enough to sterilize our gut?
Just enough might not be enough.
It almost certainly isn't. The RDA prevents deficiency diseases. It does not necessarily support optimal physiological function across all these other systems.
So let's bring this down to earth for everyone listening. We've covered a lot of biochemistry. If I'm listening to this and I realize I only use sea salt and I don't drink milk, what is the move?
The first move is just awareness. Check your salt. If you love the taste of sea salt, fine. But maybe consider having a canister of iodized salt for cooking water pasta, potatoes, where you won't taste the difference.
And for pregnant listeners.
Flip the bottle. Look at the label of your prenatal. If it doesn't explicitly say potassium iodide or iodine in the ingredient list, you need to switch brands or add a specific supplement. The stakes are just too high to guess.
And for the vegans.
You are in the high-risk category. You almost certainly need a supplement. Seaweed is an option, but because of that variability we discussed, the wild card factor, a standardized supplement with potassium iodide is much, much safer.
It's funny, we usually end these deep dives with a complex, nuanced take, but this one feels like the solution is incredibly cheap and simple, yet the problem itself is invisible.
That's the danger. It's invisible until it's too late. You don't feel your IQ dropping. You don't feel the breast tissue changing until years later.
So the final thought for today.
I'd ask the listener to consider this. We spent the 20th century celebrating the eradication of the goiter. We ticked the box. But with what we now know about the NIS and the role of iodine in the brain and the immune system, did we declare victory too early? We treated the symptom, but we might have forgotten to nourish the whole system.
A sobering thought for the next time you're in the spice aisle. Check your labels, everyone. Thanks for joining us on the deep dive, and we'll see you next time.